Hello humans, Mega here, creator of the inventory and item blueprint system. Today we're going to use my system to create this flyable UFO that can levitate and suck up these derpy looking cows. Our UFO will store these cows in our ship's inventory, and we can take out and add items to our ship's inventory while we are flying. And when we land, the ship is going to spawn a container for us to loot any items left in it before it flies off, back to the mothership. It sounds like a lot, but my inventory and item blueprint system is going to handle a lot of the heavy lifting for us, letting us just focus on the fun parts instead. And the idea for this tutorial was requested by someone just like you. So if you like this lesson and would like to see me create more, please let me know in the comments below. Let's get started. There are a few prerequisites we need to take care of before we dive in. First, create a new copy of my inventory and item blueprint system. After you open the new project, navigate to the blueprints folder and open up the player controller. Make sure you see project version 1.01 or higher in comments like they are on my screen at the top left of the blueprint. If you do not see anything here, you will need to update your copy by restarting your Epic launcher, and from the library, search for the inventory and item system. You should see a button that says update on it. Click this button, then create and open a new project when it's finished updating. Next, we're going to need two meshes, one for our UFO and another for our cow. We're also going to need an icon for when it's in our inventory. Make your own or see the link in the description or comment section to download a copy of the ones I created for this tutorial. Create a new folder in your content folder called UFO and import these assets to it. If the assets are missing their materials when you import them, you can just go ahead and add them by opening up the mesh and then using the reference names for each slot. And the materials I'm using here can be found inside the inventory and item system demo materials folder. Go ahead and open up the icon and set the texture group to UI and the compression settings to user interface. Now create a new level. I'm going to select open world, but basic level is fine too. Let's go ahead and save this level to our UFO folder. I'm going to call my level map_UFO. Now go ahead and set up your environment to your liking. I'm just going to throw a few settings at the directional light. And to make things a little bit darker, I'm also going to add an unbound post-process volume that I use to limit the min and max exposure brightness. I'm going to set both of these to 1. Now I'm just going to reposition my directional light and tweak the intensity a little bit. Perfect. Now I'll go ahead and click the World Settings tab, and from the Game Mode override, select Example Game Mode. This will select our player controller for us. I'm also going to add a player start to this level. Go ahead and press play. And when you press the I key, it should show your inventory. And if you had anything in your bag from the previous level, it should still be in there. So here's our UFO static mesh. And let's break down our goals for it. First, we have to create a way to get inside of it, and we can use the interact system for this. Next, we want to be able to fly it around. Finally, we want to have a way to pick up cows and store them in an inventory on the UFO that we can also interact with our own inventory. So let's approach these goals one at a time. We will start out with our way to get inside of it. Navigate to the Blueprints Interactables folder and make a child of the class BP Interactable. Move this child to your UFO folder and name it BP_UFO. Go ahead and open it up and select the static mesh for our UFO. Then just bump up the sphere radius of our interact range collision just a little bit. I'm going to set mine to 400. Compile, save, and drop one of our UFOs into the level. Then press play to see if you can run up to it and get the prompt to press E to interact with it. If you do not see this, you either did not make the BP UFO a child of the BP Interactable, or the sphere radius of the interact range component on the BP UFO is too small and needs to be increased. The yellow sphere should expand just a little bit beyond the edge of the mesh. Next, head on over to the event graph and override the function called action. Action is a custom event from our BP Interactable blueprint that is called whenever the player presses E within the range of an interactable object. This is what we will use to enter our ship. Now we can't just possess this interactable object because this object is not a pawn. We can only possess pawns with our controller. So the solution here is to use our interactable to spawn the pawn we need to possess, then make our controller possess it. We will need to create our pawn before we can continue inside this interactable BP UFO. So head back over to the UFO folder and create a new blueprint, but don't just select pawn from the list at the top. From the all classes part below, select default pawn. We want to use the default pawn because it has flying built into it. Name your new blueprint BP_flyable_UFO. Open this blueprint up and add a static mesh to it. I'm going to name my static mesh UFO. Now go ahead and set the mesh for the static mesh to our UFO. And now let's head back over to the BP UFO blueprint, and on our action event, spawn a BP Flyable UFO, using the spawn actor of class node. Set the spawn transform to our actor's transform using the get actor transform node. Set the collision handle override to try to adjust location but always spawn. This will ensure that our flyable object will be spawned, and if it can't be at the exact location, to try and adjust it just a little bit. Then from the controller node on the action event, pull off and select possess. Hook the in pawn up to the return value of your spawn actor. Next, add a destroy actor node to destroy our original interactable object now that we have a real version of the pawn. And we need to add destroy to one more actor the pawn our controller leaves in the world when we get into the UFO. Pull from the controller node and select get controlled pawn. Then from its return value, pull off and select destroy actor. I'm going to add a sequence in just to clean this up a little bit and make it easier to read in the future. Next, return to the viewport of your BP Flyable UFO and add a spring arm and a camera as a child of the spring arm. Increase the spring arm's target arm length. I'm going to go with 1200 for mine. I'm going to position the relative location of it up just a little bit on the Z-axis. Also on the spring arm, select use pawn control rotation. I went ahead and unchilded the spring arm from the UFO, and I selected the movement component and changed the settings for the floating pawn movement. This is what controls how fast the ship is when we are flying it, and I'm setting the max speed to 3600 and turning boost to 25. But this is the kind of thing you just have to feel to get right for your own liking. Just remember, if you want to change the UFO speed and control, this is where you do it at. If you can't climb altitude and you're getting stuck in the ground, simply go to the world actor and raise it up on the Z-axis just a little bit. One more thing I would like to do is show a copy of our skeletal mesh inside the glass dome of the ship when we take control of it. We are flying it after all. And to do this, we simply need to add a skeletal mesh and select skm_quinn_simple for the skeletal mesh. Then for the animation blueprint, select abp_quinn. Position and scale quinn until you're happy with how they look inside the ship. Well, we do have this emissive green glow at the bottom, but to really pull the effect together, we need to add a spotlight. I'm going to set it as a child of my UFO static mesh, and I'm going to rotate it so it's facing down. And I'm also going to play with the settings until I get a nice bright green light. Yep, that looks good. As soon as we board our UFO, I want it to smoothly raise up off the ground and play a little sound effect to go with it. And to do this, we first need a reference to our current UFO location. So go ahead and create a get actor location node and promote it to a variable. I'm going to call my variable UFO_location. Hook this up right into your begin play. Next, add a timeline. Timeline is how we're going to smoothly ease our UFO from the ground to the air, and leave the execution pin into the play from start. Open up the timeline and add a new float track called alpha to it. Then set the duration of the timeline to 2 seconds and drop 2 keys into the timeline with shift click. Set the first key to a time of 0 and a value of 0, and set the second key to a time of 2 and a value of 1. Select the first key and press 1 on your keyboard to set the auto key interpolation. This will give it a nice realistic ramp up to the easing. Compile, save, and close the timeline and return back to your event graph. So using this alpha value, we're going to figure out exactly what our elevation and our height should be for each step of the timeline. And we're going to do this using a lerp. Drag the alpha node that auto-linked into the A input down to the alpha input instead. And for the A input, we're going to use our current location that we saved in the variable. And it's important to use this variable because you don't want to get the actor's current location every time this updates by just using a get actor location, because this value will be changing every update as well. And this causes our lerp to think we are stretching out the value the closer we get to the endpoint. I'm going to split our location node and use the Z value as our input into A. Then for B, I'm going to manually enter in the height I want our ship to ascend to. For my world, I'm going to go with 350, but adjust yours as you need. You may also just want to use an increment from your saved location. And to set our Z position, we're just going to use a set actor location, and I'm going to split the input and feed in our calculated value using the timeline, and our fixed values using the save location prior to the start of the timeline. Let's see how that looks. Now when we hop in the ship, it automatically rises, and it feels like a good speed and rate. But one last thing I want to add to this is a sound when it starts to rise. I'm going to use a play sound 2D, but you could also use a play sound at location or attached. I'm going to select the enter play engine provided sound. And the only thing I don't like about this sound is a little tick at the start of it. And to get around that, we're just going to adjust the start time on the play sound node. And after some testing, 0.2 sounds like a good amount of time. I'm also going to drop the pitch to 0.1 to make it more drawn out. Here's what it sounds like now. Now head back to your blueprint and take a minute to tidy it up and add some comments. Keeping it clean as we go and adding comments will make it easier to understand in the future when we come back through to make changes or fix bugs. Next, we're going to create the logic to get out of the UFO when we press the key binding. I'm going to use the Z key for this. Visually, I want to give the impression that the UFO is dropping us, the player, off. I'm going to start this event off by using a do once because I don't want the player to be able to mash the button repetitively, which could cause some issues. First thing we need to do to handle this drop-off process is lower our altitude to a reasonable level. That way we don't just drop the player off in the middle of the sky. And we can reuse some of the logic we just wrote to handle this particular event, and the only thing I'm really going to change here is the value we have in the alert for the B input. And I'm going to set this to 220 instead of 350. Let's see how that looks real quick. Yeah, that should do. Next, we want to kick our player out of the UFO and respawn them in the world. Let's head on over to the example player controller. We will set our respawn logic over here so we can reuse it in other parts of our project. Go ahead and find some room in the blueprint to work with and create a custom event. I'm going to call mine respawn character. From this event, drag off the execution pin and select spawn actor from class. Then select example character as your class. From the return value, go ahead and drag off and select possess. Then let's pull out our nearby interactables variable and just clear it, just to give it a fresh state for the new character, in case anything was left lingering in it from before. And the last thing we want to do here is hook up the spawn transform to the event. That way we can handle the spawn location wherever it may be triggered. Return back to your BP Flyable UFO and from the graph, create a Get Player Controller node. Then lead it into the Get Player Controller message. This gets our example player controller for us using a simple interface method. And before we go down the next rabbit hole, make sure you tidy up the blueprint and maybe add some comments. Now from the controller output of our Get Player Controller message node, drag off and select Respawn Character. Then split the transform on the input. Then go ahead and split the location input that appears. Create a Get Actor Transform node and split the location pin on that one. Then drag X and Y from this node into your Respawn Character node. Also hook up the rotation and scale. For Z on the Respawn Character, go ahead and set it to 200. And this should be 20 units below where we told our UFO to set the elevation to. Let's check it out. It looks like it works. This little sphere here is part of the default pawn on your UFO. And we can hide it in game by traveling back to our BP Flyable UFO and selecting the mesh component. And then from the details panel, select hidden in game. Let's test it again. Yep, that's what we want. Now I'm going to add a sequence here for the next part, and I'm going to also clean up the blueprint and add some comments. Now that we're out of our UFO and back into our character, we need a way to get rid of the UFO visually, and just destroying the actor at this point adds nothing to the coolness factor of our game. So what I want to do is make the UFO fly away slowly, raise altitude, then shoot across the sky at a ridiculously fast rate. You know, just like a real one. First thing we need to do is update our saved UFO location, and we can just duplicate this from above and plug it in. Then let's create a new timeline. And we have two goals with this timeline. Move the UFO to a location and raise its altitude. Let's do some prep work for the location side. And to do this, we're going to use the forward vector of the camera and just multiply it by a ridiculously large number. Since this is more of a visual effect and our world is small, we don't really have to account for the camera's current location, but you might need to add it to this value if your world is really big. I'm going to set mine to 25,000. Let's also drop in our UFO location and break it to expose the X, Y, and Z. Now open up the timeline and add a new float track. I'm going to call this one Z, as it will control our altitude. Add a few keys and plot out how you want your altitude gain to work. For mine, I wanted it to be a slow gain at first and then start to climb faster as we get to the end. Make sure your first key is at a time 0 with a value of 0, and your last key is at a time of 5 and a value of 1. Also make sure none of your keys go below 0. Let's create another track. This one is how we're going to handle getting from our current location to our target location. I'm going to use 2 tracks because we want them to each reach their goals at different rates. I'm going to name this second track XY. And this one is a lot like the other ones we created previously. 2 keys, the first at time 0 with a value of 0, and the second at time 5 with a value of 1. Then select the first key and press 1 on your keyboard to set up the auto key interpolation, which gives us this nice smooth ease. Compile, save, and close your timeline to return to your event graph. And we know we're going to need a lerp and a set actor location again, so let's go ahead and duplicate these from above and hook our set actor location into the timeline. Hook the Z pin up from your timeline into the alpha pin of the lerp. Then plug the output of that into the Z pin of your set actor location. Plug the Z pin or saved UFO location into the A pin of the lerp. For the B pin, I'm just going to enter a value of 10,000. Go ahead and duplicate the lerp 2 more times, then hook the X and Y pin from your saved UFO location into the A pins of the new lerp nodes. Then plug the X and Y pins from your forward vector calculation into the B pins of the new lerp nodes. Then hook up the return values into your set actor location. Next, we need to hook up the X and Y output from our timeline into the alpha for both of the new lerp nodes. Let's go ahead and check it out. Now we want it to shoot away across the sky at a ridiculously fast speed. Let's tidy up the blueprint before we continue, then duplicate one of our single track timelines that have a 2-second duration. The only thing I'm going to change in this one is to remove the easing and make it linear instead, and I'm going to do that by selecting the first key and pressing 4 on my keyboard. Compile, save, and close this timeline, then hook it up to the finished execution pin of that previous timeline. We're also going to need to update our UFO's save location variable, so let's do that before we run the timeline. Then let's create a references variable and break it. Create a lerp node and hook it in the alpha pin from the timeline into the alpha pin of the lerp. Plug Z from your saved UFO location into A and set B to 300,000. Now I just want my UFO to shoot straight up at this point, but if you want to add a little more flair to yours, you can lerp an offset of your X or Y positions. For example, from our X pin on our saved UFO location, drag off and create a multiply node and multiply it by 1.5. Duplicate our lerp again, then hook the X pin from our save location into the A input pin, and from our multiply by 1.5 node into our B input. Then just make sure you hook up the alpha pin to your timeline. Since I just want mine to shoot straight up, I'm going to leave it unhooked for now. I'm going to go ahead and duplicate a set actor location node and hook up the output of this lerp into this X pin of the set actor location. Hook the Z pin up from the other lerp into the Z pin of the set actor location, and finally hook the output from our saved location Y into the set actor location for Y. And the last thing we need to do is the sound effect. I'm going to use a spawn sound attached, then pull from the component pin and select root component. I'm going to use the engine provided dockable window close sound, and just tweak the starting time to 0.2 and the pitch to 0.1. Let's try it out. Oh, I like that. Next, we need to add our cow. And to do that, navigate to the Blueprints Variables Data Table folder and open up DT_item. Then click the Add button on the menu bar to add a new row. Set the row name to cow, then fill out the rest of the details. For the icon and static mesh, select the ones we imported. You can also adjust the stack size to your liking. I'm going to set it to 0, which is unlimited. And the last thing we need to do here is set the scale to 0.5 for X, Y, and Z, because our cow is kind of big by default, and this is an easy way to handle that. Save your data table, then navigate to the Blueprints Interactables Items folder and drop a BP interactable item into your world. Select the actor, then from the Details panel, for item row name, enter cow exactly as you entered it in the row name on the data table. Go ahead and press play, and then run up to the cow to see if you get the prompt to press E. Go ahead and press E, and then open your inventory by pressing I. You should see the icon in your bag, and when you hover over it, you should see the information you entered for the text. Test dropping the cow by dragging it from your inventory and dropping the icon into the world. You should see the cow when you confirm the drop. Let's go ahead and duplicate the cow a few more times. And what I want to do next is use our spotlight to levitate the cows, collect them, and then we'll store them in an inventory component that we attach to our UFO. Navigate back to your Flyable UFO BP and head into the viewport. We're going to use two collisions here. The first one will be used to levitate the cows, and the second one will be used to collect them when they get close. This first collision is the one that will make the cows overlap when they levitate, and to do that we're going to use a capsule collision. Go ahead and play with the half height, radius, and positioning of it until you're happy with the size of it. You can make it visible, then enter play mode to get a feel for the settings you're entering here. I ended up going with a half height of 600, a radius of 200, and a location offset on Z of -430. And while I'm in here, I'm also going to shift the camera so it's tilted downward just a little bit. Let's say 10 degrees on the Y should do it. I'm also going to rename this collision vacuum as a reminder of what its purpose is. Next, let's add the other collision, and this one is going to be a sphere. And we'll use this one to do the actual collecting when the cows get near our ship. I'm setting the radius to 240 and moving it up on the Z-axis, so just the bottom half of the sphere is exposed to the bottom of the ship. This will be our collection area. Head on back to the event graph and find somewhere to work. Right-click on our vacuum and select Add Event. Then select On Component Begin Overlap. Then pull off the other actor pin and do a Cast to BP interactable item. This way we know the item we are overlapping is one we can pick up. Next, promote the result of this cast to a variable. Go ahead and delete the set variable, because what we really want here is an array, not a single. So click on the variable we just created, and switch its type from single to array. Then rename the variable. I'm going to call mine Levitate Items. Go ahead and drag a copy of this variable out, and place a Git node. From the Git node PID, drag out and select Add. Plug the output from our cast into the input on the Add node, and then hook the execution pin into it. Next, right-click on the Collector Sphere collision, and do an Add Event on Begin Overlap. And let's just move this one above for now. We'll come back to this. And the last overlapping event we need to do is with the vacuum. So go ahead and right click on it again, then click Add Event, then select On Component End Overlap. And like the Begin Overlap, we're going to need a cast to our interactable item to make sure it's a valid type. If it is, we're going to remove it from our array. Now the fun part. Let's levitate some cows. And to do this, I'm going to use a throttled event tick. Click the Class Defaults button on the main menu, then set the tick interval to 0.1. This will limit how often our tick for this actor actually occurs. Now, even though we're throttling our tick, we can be just a little bit more efficient by turning it on and off as needed. And we only ever need to turn it on after we add something, so we can just plug that in right here on the overlap event. And let's make sure it's off by default by clicking on Class Defaults and unchecking Start with Tick enabled. Now on our tick, the first thing we're going to do is see if our array of levitating items is empty. If it is, then we're just going to shut tick off. But if it's not empty, then that means we have items to levitate. So create a for each loop to iterate through each of our items. And for each of these items, you're going to want to add an impulse to the static mesh component. And this is what will determine how fast our vacuum sucks them up. The impulse should be on the Z. I started at 50 but ended up at 100 for the final value. Make sure you also enable velocity change. So let's recap. When we overlap an item, it will turn the tick on. The tick will go at a throttled rate of once per 0.1 seconds. Then when the tick detects that it no longer has work to do, it will shut itself off. If it has work to do, it will iterate through each of its items, applying an impulse on the Z-axis. Let's check it out. Next, we need to actually collect the cows when they get close. But before we move on, let's tidy up our blueprint and make some comments for our future self. Now to collect the cows when they get close to the ship, we're going to use this component begin overlap on the collector sphere. Let's first add our inventory component. Search for and select AC inventory from the list. Then select the component and from the details panel set the slot count to whatever number you would like for the number of slots in the inventory on our UFO. I'm going to set mine to 12. I'm also going to click Save Loot. Now on our component begin overlap, let's cast to our BP interactable item to make sure it's valid. Pull from the return pin of the cast and get item row name, and also get the item quantity. Next, pull down a reference of your AC inventory component and drag from its pin and select Add Inventory. Go ahead and hook all the pins up. Then we're going to do a destroy actor on the cow to remove it from the world. We're also going to remove the reference of the cow in our array of levitating items. I'm going to switch the position so the remove is actually handled first. One last thing I want to do before we test is create a way to easily see the contents of this inventory. And for right now, we can use the debug loot function on our AC inventory component. This will spit out the contents of the inventory into a print string at the top left of the screen. Let's try it out. As you can see, when we pick up cows, our inventory is getting updated. Now go ahead and delete the debug loot for now. We were just using it to make sure our items are being added properly. In a little bit, we're going to show a UI for it instead. But before we continue, you know what to do. Let's clean up that blueprint and add some comments. Now that our UFO is able to pick up and store items, we need a way to get those items out of it. And there are two different ways I want to handle this. The first method is when we exit the UFO. I want the ship to drop all the items into a container that we can then loot as the ship flies off. To accomplish this goal is really easy. We are going to want to have this occur right after we spawn our character back in the world, so make some room next to where we call our respawn character event. Now add the AC loot component to our blueprint. Then select it, and on the details panel for loot type, select drop inventory in the world. Also make sure drop loot chest on handle is selected. By default it should be. Now just drop a reference to our AC loot component in the event graph, and from it drag off the pin and select handle loot. Hook up the execution pin, then connect the get player controller node into the controller reference of the handle loot method. That's it. See how easy that was? Let's test it out. Now we're going to set up our UI for the inventory on our UFO. First, decide what key you want to use to show your ship's inventory and create an event for it. I'm going to use the R key. Then get the player controller and lead it into a get player controller message to get our example player controller reference. From the execution pin, drag off and select create widget. Now our first instinct here is to use the storage container, but we can't really use this because it needs a reference to a world container object. So how do we work around this? Navigate to the UI storage container and UI's containers storage container. And what we really want to do is make a child of this storage container for use in our vehicle. But when we right click on it, we don't see a way to make a child. This is because it's handled a little differently for widgets. From the context menu of the folder, create a new widget blueprint. Then from the all classes list in the window that appears, select our UI storage container. Go ahead and name this one UI vehicle container. Return to the Flyable BP and set this widget on the create widget node. Now open up the original UI storage container and copy everything connected to the construct. Everything we need to change to make this work on our vehicle can be handled in this construct or through overrides. Now open up your UI vehicle container and paste everything you just copied. Now we just need to update all the parts that are referencing this container variable. Let's start off with this set container inventory node at the top. Let's feed it in a reference to our vehicle inventory. And to do that, we need to create a variable we can pass from our create widget. From the container inventory node, input, right click and select promote to variable. I'm going to name this vehicle inventory. I also want to get a copy of our inventory from our component and feed it into this items map on this widget. It should be on the variable section. If you do not see it, click on the gear and select the option to inherit. This set text here is used on the container title bar. Let's promote this to a variable and name it vehicle name. Next, let's override the event setup bindings. This is where we can set up the logic that needs to happen when the inventory in our vehicle changes. Drop a reference to our vehicle inventory into the event graph, and from it select bind event to inventory changed. Drag from the red square and create a new event. Name your event. I'm going to call mine vehicle inventory changed. When this event triggers, I'm going to have it just update the contents of our items map based on the current inventory. Then tell it to build container inventory, which is a method on our storage container parent. We also need to set up the unbind event handler, and we can do this from the destruct event. Drop a reference to the UI item system into the graph. It should be on the variable section. If you do not see it, click on the gear and select the option to inherit. From this variable, drag from the pin and select get player controller. Then convert it to a validated get. Then from the player controller pin, pull off and select set transfer target. Leave the value on this blank. When we build our inventory, this is set, and this is how we know what container we can transfer items to from our inventory. From the vehicle inventory node used on the event setup bindings, drag off from it and select unbind event from inventory changed. And from the red square on this one, lead it into the vehicle inventory changed event. Next, let's override the close window event. This is what's called when the little X at the top right of the window is clicked. What we want to do here is tell our UI system to hide the inventory, then release our mouse. Finally, we're going to remove our current widget from the parent. Go ahead and tidy up the blueprint and add in some comments. Also set the vehicle inventory and vehicle name variables to expose on spawn. Then head back to your Flyable UFO blueprint and refresh the Create Widget node. Hook your AC inventory node into the vehicle inventory input. Also drag from the AC inventory node and get the inventory map and plug that into the input for the items on the Create widget. Get a reference for the UI item system from the controller pin and plug that into the Create widget as well. Next, set the vehicle name. I'm just going to type UFO here. Connect the controller to the owning player. Then duplicate the reference to the UI item system and hook it up to the reroute node. From this node, drag off and select Center Widget on Viewport. Plug the return value of your Create widget into the widget input on the Center Widget on Viewport node. Set an offset on the X field to -180. This will nudge the vehicle storage over to the left a little bit from the center. Now to get our vehicle inventory to close again when we hit the R key when it's already opened, we need to save a reference to our created widget. So go ahead and promote it to a variable and hook it into the execution pins. Then at the start of this event, pull out a reference to this variable and convert it to a validated get. If it's not valid, then we want to proceed with everything we just created. If it is valid, we want to pull from the output pin and select Close Window. Then we want to clear this variable by dropping a set node in, but not setting anything in the value for it. Next, I want to create a lot more cows. 100 should do. Let's try it out. It is working, but we really need here is some sort of auditory indicator that we are picking them up. So let's go ahead and add a sound real quick. Return to the event graph, and on our collector overlap event, make some room between the remove levitate item and the destroy actor. Let's plug our sound in right here. Go ahead and add a place on a location, and we can use a get actor location. For the sound, I'm going to use the engine provided teleport mode entered. And I'm just going to lower the pitch a little bit. Let's say it 0.8. Also make sure to hook up the destroy actor pin. Go ahead and take a minute to tidy up your blueprint, add some comments, make it easier on your future self. Let's try it out again. Okay, so we might need to play with the sound a little more, but it's definitely better than nothing. The storage is fully functional and you can transfer from it to your inventory and back. One bug I noticed with it is if we close the inventory window, we lose our mouse even though the storage is still open and needs it. This is because our event to hide the inventory does not know about our vehicle storage container yet. Go ahead and open up the UI item system widget blueprint in the UIs folder, then navigate to this section with the hide inventory event. See these variables we are checking to determine what we should do with the mouse? We need to add a reference to our vehicle storage here. So create a new variable of the type UI_vehicle container. Then just plug it in like all the others. I'm going to change the way this works in a future version, but for now, whenever you add a new unique UI, you'll need to append them here. Next, we need to handle setting and unsetting this value. So return to your UI vehicle container blueprint, and in the construct, drag out a reference to a UI item system. Then select set and the variable name you just created. For its value, just use a reference to self. And when we close this window, we want to set the value of this to nothing. So make some room before the remove from parent node. Then drop in another reference of the UI item system. And then set this value again, but this time we're going to set it to nothing. And don't worry about this call node, you won't need that. That was just for testing. Now when we close our inventory with the vehicle storage up, we still have our mouse. And the last bug I want to fix is part of our exit ship logic. If we have the inventory open when the vehicle leaves, we can still interact with it. We just need to call our close window event right after we handle the loot on our exit ship logic. And you can use a validated get to make sure this is only called when it is actually set. Let's try it out. There we go, much better. Thanks again to Brayman for suggesting this tutorial. There you have it, our flyable UFO that we can hop into and control using our interaction system as our starting point. We can use this UFO to levitate and collect our derpy looking cows that when picked up go into the ship's inventory as items that we can then transfer to and from our own inventory, all while controlling the ship. Then when we get out of our ship, any items that are left over are spawned into a loot crate using our loot system. If you run into any bugs with this lesson or have any questions about my inventory and item system, please reach out. I'll do my best to help you. Thanks for watching and I'll see you next time. Yep, that looks good.